All right, number 22. I'll let you read the context, but essentially they want to know, is there convincing evidence at the alpha equal 0.05 level that this proportion is different than this proportion, that the proportion of patients that took aspirin alone and experienced strokes is different from the proportion of patients that took aspirin and dipyridamole. Dipyridamole. That's what we're going with. No idea if that's right, but that's what we're going with. So we want to do a hypothesis test. The first thing that we need to do when we run a hypothesis test is we need this four-step process: state, plan, do, conclude. So let's start with the state. State looks like this. So big, long statement with a lot of context here, but the key is, number one, tell them what kind of test. So we got a one-tailed hypothesis test. Number two, tell them the alpha level of that test. And number three, provide context. So your context is to see if the proportion of patients who took aspirin and dipyridamole and had strokes is lower than the proportion of patients who just took aspirin and had strokes. Mouthful, but that's the gist. Next step in this state portion is to do the null hypothesis and alternative. The null hypothesis looks like this. And it essentially says that there is no difference in these two proportions: the proportion of patients that took aspirin alone and had strokes, and the proportion of patients that took aspirin and dipyridamole and had strokes is no different. Alternative hypothesis looks like this. And this hypothesis basically says if we get a positive number out of this, that means that this proportion, the proportion of patients that took aspirin alone and had strokes, is greater than, so a higher proportion of strokes that took in patients that took aspirin, as opposed to the proportion of patients that took aspirin and dipyridamole and had strokes. So again, a mouthful. That's the gist. Last part is we want to define those parameters that we just introduced, and here's how we do that. So, big picture, we're defining what this means, P sub A, and what this means, P sub AD, within the context of the problem. So again, under the state, we want to say what kind of test we're going to run: one-tailed or two-tailed, hypothesis test, state the significance level, give context for what you're trying to figure out, for what that test is going to inform you on, null hypothesis, alternative hypothesis, define your parameters. So we're going to go ahead and move on to the plan portion here. This one's a little bit different, and it's a little bit different because of this. It's a randomized comparative experiment. So first of all, let's check out what normally are our three conditions for a proportions test or difference in proportions test. So they look like this. So here we've got our three conditions: random less than 10%, NP/NQ greater than or equal to 10 for each proportion here. So a little bit different here. We check out the first one. Are the samples taken randomly, or is there randomization involved? We do have a randomized comparative experiment, and so this one is checked off because it's a randomized comparative experiment, meaning that people are placed into groups randomly and or chosen randomly. The second one is the one that's a little interesting and different in this particular case. So we don't have a population necessarily of these people. We're running an experiment, and because we're running an experiment, we don't have less than 10% of the population. We don't and we don't need it. So because this is a randomized comparative experiment, we're okay with this. This checks out. We are going to have. We're also going to look at, is this distribution normal, and we can look back up here, and we have 206 successes. So again, we're not doing n times p. We're just looking at number of successes. That's greater than 10, and then 1649 minus 206 is 1443. So that's quote unquote a failure, or a failure in this case is actually not having a stroke. So that works for the first one for aspirin alone. When we look at aspirin and dipyridamole, we've got 157 quote unquote successes. So that's when a stroke does occur. We've got 157 of those patients, and 1650 minus 157 is 1493. Those are failures, quote unquote, or people that don't have strokes in this particular case. So our distribution, our sampling distribution of the differences is going to be normal. So we can go ahead with our two proportion z-test, and that's what we'll do in the next step here. So we got a two proportion z-test. And anytime we run a two proportion z-test, a majority of this is going to be done in our calculator, but we want to make sure that we report the relevant information. And the relevant information in this particular case is our sample proportion. In this case, it would be the differences, but because it's a proportion test, we're going to have a pooled p-hat. And again, because we're operating under the assumption that there is no difference between our two proportions, we can find a pooled p-hat by combining the number of successes. So that's going to be 206 plus 157 over the total number, which is 1649 and 1650. That'll give us our p-hat pooled. Little calculator work of, first thing we need to do is this up top. So we need to calculate our p-hat for each individual sample. And notice that I take this pretty far. I mean, I'm going, well, it's 7 decimal places in each one. And the reason I'm doing that is because these are such small decimals, when you truncate those decimals or round them, you got to be really careful, because ultimately you're rounding 2, 3, 4, 5 different times within these problems. And ultimately that can lead to a huge change in your z-score, which obviously throws your test off. So anytime you're actually calculating these, try not to round, if you can help it, until the end. So let's check this out. So we got our p-hat for the aspirin, we got our p-hat for the aspirin and dipyridamole. We're going to look at the differences between those two. So 0.12492242 minus 0.0951515. So we're looking at the differences between our two proportions, and then minus the mean. And again, it's minus 0 because we're running this test under the assumption of our null hypothesis that there is no difference between the two. Our denominator for the z statistic or z-score is going to be based on this p-hat pooled. So I'll piece that together here for in a second, but it's based on this being our p-hat, our total combined p-hat, and it looks like this. So here's my denominator. I've got the p-hat pooled times the complement of it divided by the sample size for my first sample, and then the p-hat pooled times the complement divided by the sample size for my second one. Plug that into your calculator very carefully, and you should get about 2.73 for your z. All right, so what do we have left to do? Just under this do step, we just have to report the p-value. So it's time for the calc, and then everything's kind of downhill from here. So let's go over to the calc. We're going to go to Add Calculator. This is on the TI Inspire menu, Statistics, Stats Tests, and this is a two proportion z-test. And we just need to enter our information here. So I'll go ahead and do that. So there's our information. This is the number of successes, or the number of people that took just aspirin and still had a stroke. This was the number of people that took aspirin and dipyridamole and had a stroke, and then these are the sample sizes for each of those samples. And remember the alternative hypothesis. We're trying to figure out if the proportion of people that took just aspirin and had a stroke is greater than the proportion of people that took aspirin and dipyridamole and had a stroke. So we want to test to see if this is statistically bigger than this. So we're going to run our test. That spits out, there's our z-score, so that kind of confirms that little calculation we did. And then here's your p-value. And again, it does give you the p-hat pooled down here if you wanted that. But this is the thing that we're interested in so that we can go make a decision on our null hypothesis for our test. So p-value equals 0.00314. So back here, we've reported our p-value here, and last thing to do is to make a conclusion on this thing, figure out if we've got a significant difference between these two proportions or not, and then provide some context. So first thing we always do in a conclusion is take our p-value, compare it to our alpha level, and make a decision on the null hypothesis. So here's what that looks like. So we report the p-value, make a decision on the comparison of the p-value and the alpha level. So here we're rejecting the null hypothesis. And then the rest of it's really just context. What does it mean that we reject the null hypothesis within the context? And that looks like this. So here we are, the proportion of patients that took only aspirin and had strokes is significantly greater than the proportion of patients that had strokes while taking aspirin and dipyridamole.